people, what's up? Just doing a quick explanation on how the vortexes work on planet Earth. Mainstream's not going to get this because they haven't been taught to get this. So this is theoretical physics. It's actually not theory, it's fact. But anyways, we'll have to play along until they catch up with us, you know. They can use the big words perturbation, undulation, and best of all, contemplation. Anyways, here we go. Here's the storm that we're talking about right here, right now. Big thing right here. Cat 5, 180 miles an hour. Hurricane Dorian. Gonna come in and smash into the United States, but maybe not. Maybe not. Now, the way these things work, you go back to Shaughnessy's Law of Gravity, 1 through 7. With the pyramids of volcanoes, it's the 180-degree theory, 180-degree system. Vortexes have, you know, everything that happens on one side of the planet happens on the other side of the planet. So currently, right now, people that know my theory, I'll get into it a little bit deeper in a minute. But South China Sea just got up a little bit too much caffeine. South China Sea has a vortex, right? Okay, right there. Now that is 180 degrees opposed to Hurricane Dorian. All right. Now you look over here, you'll also see, you know, vortex over the Aleutian Islands, and straight across you have another one over here in the North Atlantic. That might be in the I think it's above the North Atlantic. But anyways, you can see the north of Scotland right up here, right? And then you have one right here. So again, like these things, they all have opposites on 180 degrees opposed to each other in the same approximate latitude. Now, what is going on when you get these massive vortexes like this? We're talking, you're hitting the upper peaks of 1 billion horsepower, above 1 billion horsepower, hundreds of billions of horsepower. All right, so when you're manifesting and concentrating energy of that magnitude into a tight focal point, you're affecting the gravitational field on the planet, unbeknownst to the mainstream brain machine. All right. This is a fact. You get the moon on one side of the planet with the high tide, the opposite side at the exact same time. You got a high tide over there. You have a high tide moon and a moonless high tide. This is, you know, it stretches the Barry Center out, this, that, and the other. However, this is a little bit different because we're playing with a tight vortex, magnetic gravity, and heat and everything else. But once you start eclipsing into the hundreds of millions and into billions of horsepower of energy, okay, you're actually creating massive disturbances in the natural vortex, the natural equilibrium of the planet. So again, we'll just zip it around. So if we just turn around, all right, keep going. 180 degrees, right up the coast of south of Hong Kong. Right there, you get this massive vortex. Now, if this thing stays straight, steady, and doesn't go west, then it should prevent Dorian from making a direct impact and going into the Gulf of Mexico. All right. If this thing stays steady, it'll lock in. These two vortexes are locked in with each other. All right, so that's a good thing because you don't want a Category 5 hitting any populated place on the planet at any time. It's not good. It's bad juju. So that's it. That's all I can tell you. It's very simple. I just wanted to throw this out there. You know, all these massive storms. I've been watching this for years. All these massive storms, all 180 degrees. On the same approximate latitude, you have another storm. You have another massive vortex. You have a vortex matching up with vortexes. Like I said, bam, bam. you got a little one here. You actually have two here opposed to each other on the poles. If you go to the south pole, there's always massive vortexes over here, and they're 80 degrees opposed to each other. I mean, the big ones anyway. 1, 2, there you go. 3, 4, crisscross, right? It's just the way the system works. Now, you're not going to get this on the big brain drain, meteorologist, but I mean, they're doing a great job. They're doing what they're doing, but this would take a lot of the guesswork out if they could incorporate the actual energies that are involved in guiding storms in today's day and age. Okay, so again, you can see these. When I say 180, I'm talking about it's cutting right through the planet. It's that's it. That's how the gravitational fields work on Earth and on anybody. On the sun, the other planets, you name it. Anyways, yeah. So that's about it. Just putting that out. Go check out there's a lot of good news out there. The Weather Channel, they're doing a great job. But like I said, as long as this thing does not go west into the mainland, right? This thing should stay stationary with it. I mean, it's going to drift. You also have the energies, the flows of what do you call it? You got the Gulf Stream. You have aloft air. You have the low pressures. You have the high in the Gulf of Mexico. There's a lot of other factors going on here. But when it comes to steering these things, it's good to have it locked in. In some particular case, it's good to have another storm 180 degrees opposed to it, locking it in and preventing it from going this way. Okay, so you can see there's like a huge flow of energy going eastwardly towards the storm, so that's going to stop it from moving in. Now we have a westerly wind trade here, as you can see in the Gulf of Mexico. So I don't know if they're talking. They say there's a high here. I get the high, but you can still see, this is a wind map, by the way. This is, you can still see the what do you call it there? There's still winds going over Florida, which is concerning to me. But as long as that high's locked in, I guess that might be upper level winds or something. But as long as that high stays over the Gulf of Mexico, it should prevent it from going smashing into the land. But it's still going to be, nobody's out of the woods yet. I mean, there's still a lot of beach erosion, floods, you name it. But if they can keep that wind off of the mainland, we should be all right. But South Carolina, man, it doesn't look good if it's just going to travel this arc that they're showing on the Weather Channel, right up the coast and back out to sea. Right here at this peninsula, this tip right here could bump into it, but hopefully by then it loses a lot of its energy. All right, take this storm seriously, people. As usual, keep the faith and give me some likes, give me some comments, and spread this stuff around. The mainstream needs help too. They need to be educated. I can't do it on my own, obviously. All right, peace out.